Hello students, we will start with a new topic which is the structure of atom. In the previous topic we have already discussed about what are atoms, molecules, valencies, etc. So here in this topic we will discuss more about who discovered the theory of atoms, the contents or the atomic molecules or the atoms or the subatomic particles present in this particle of atom, and also we will understand certain discoveries that failed and also had certain limitations with respect to the scientists who were able to find out what atom consists of. So let's start with the topic. So here we can see this is Dalton. So Dalton's atomic theory, it suggested that an atom is indivisible. So actually we know that atoms are divisible to very minute quantities, or substances can be divided into very smaller particles. So as he told, indivisible means we cannot divide into smaller particles is wrong. So as per him, the theory did not fit into the current theory of atom and atomic theory. So he discovered only two fundamental particles and he named it as electrons and protons. So that is where he proved that atoms consist of electrons and protons, and also he was not able to understand what was inside the atom, particularly whether it was an atom consisting of protons or electrons. So let's understand this once again. So Dalton's atomic theory is suggested that an atom was indivisible, so it cannot be divided further. So there is where he went wrong. So it is actually divisible. And discovery of two fundamental particles, electrons and protons. So these electrons and protons were inside the atom. He failed to say it that these electrons and protons were inside the atom. This led to the failure of Dalton's atomic theory. So let's know about the next scientist who was finding out about the atomic particles. So before that we should understand the distribution and fundamental particles of an atom. We also know that atom consists of electrons, protons and neutrons. So these are the particles of an atom and they are called the fundamental particles of an atom. So here you can see that the presence of neutrons and protons are present in the nucleus of an atom, and revolving around it is the electron. So electrons are negatively charged, protons are positively charged and neutrons are neutral. They are having no charge. So let's understand them one by one now with respect to the scientists. So discovery of electron. So first we should understand the subatomic particles which was discovered by the scientists initially. So discovery of electron was done by J.J. Thomson in the year 1897, and let us know what experiment did he do to find out the presence of electron in an atom. So you can see here that cathode ray tube, that is cathode rays, he took a discharge tube, and the cathode rays, he was able to stream a negatively charged particles that passed from the cathode to the anode. From this experiment he was able to find out that negatively charged particles, they move from the cathode to the anode, that is positively charged nature, or the particles of negative charge can move towards the positive electrodes. So you can see that he carried a cathode ray experiment wherein he observed a stream of negatively charged particle, that is cathode rays. These are negatively charged particles. They are coming out of the cathode and they move towards the anode. So he named these as the electrons which are negatively charged. So let's understand now discovery of proton. It's just the opposite of the discovery of electrons. So it was discovered by Ernest Goldstein in the year 1886. So the first discovery was of the electron, next came the discovery of proton. So he observed the same gas or the discharge of gas from the tube. So the same tube was taken as an experimental method, but here he found that he passed certain gas particles through the anode. So where he could find that from the anode there was a passing of positively charged particles towards the cathode. So he could see that different situations he applied with the anode that emitted positive particles, which he named as Canal Rays. So he named these positively charged particles as Canal Rays, and this led to the discovery of protons, which is positively charged. So next comes the discovery of neutron. So neutron are present in the nucleus of atoms. It was discovered by Chadwick in the year 1932. You can see here that the neutrons are green in color for your understanding, and the protons, which was discovered previously, it has been plus, that is positively charged, and you can see that electrons in the outer shell of the nucleus. So we will understand more about these theories with respect to J.J. Thomson's atomic model, that is, he is named as Joseph James Thomson, and he conducted the experiment in the year 1897. So let's understand what his theory says about. So his model of atom proposed that, so you might have seen a watermelon, you cut the watermelon into half, and he told that the black color seeds that you see inside are the electrons, and the rest of the part, the pulp that you see, is all the protons. So you can see here an atom is a uniform sphere of positive charges. They are togetherly a sphere of positive charges, as you can see in the watermelon, the flesh of the watermelon. Due to the presence of protons, they are positively charged, and also they are negatively charged because they have presence of electrons in the atom. So atom as a whole is electrically neutral. So what did he say? That as it consists of positive and negative charges, they are electrically neutral. So, and the positive charges are equal in magnitude. So they are dispersed equally along with the protons. The neutrons are also discharged, or they are distributed equally in the sphere. So next, coming to, let's know that, as I told, the watermelon experiment. So he compared with that of a watermelon. So you can see here that positive charges are orange in color, represented orange in color, and green colored are negatively charged electrons. So here you can see that positively charged is the pulp of the watermelon, and electron are black. The seeds are compared with the electrons or negatively charged. So what did this theory states about? This model is also known as watermelon model, or it was also called as pudding model or apple pie model. But there are certain limitations with respect to this model. What are the limitations? Actually, he failed to explain how electrons and protons, they are very near to each other. So you can see in the diagram itself that they are placed very near to each other and they are not repelling at all. How can this happen? They are like these electrons are actually moving. So how this movement of the electrons can be combined with that of the protons here? So you can see that were arranged in atoms so close to each other. They were arranged very close to each other. He was not able to explain about how they are very near to each other. So that is the limitation with respect to Thomson's model. So next model is about Rutherford's model of atom. So by Ernest Rutherford in the year 1909. So what did he use is, he used alpha particles. So alpha particle of rays were made to hit or pass through a thin gold foil. So this is also known as gold foil experiment. So he had a detecting screen here and he made to pass alpha particle, and that was made to hit through the gold foil. And what did he observe is, later on we can understand in the postulate of Rutherford's model of atom. So you can see that most of the particles passed through the gold foil. Some of them only got deviated from here, and some of them were totally deviated and could not reach the gold foil. So you can see here that this experiment is based on the alpha particles were bombarded on a thin gold foil. You can see here, this is the gold foil which is very thin. So we will understand the postulates about him and his theory. So its observations, that is Rutherford's observations with respect to alpha particle scattering experiment. So as I told that most of the alpha particles passed without any hindrance. There was no hindrance, so there were no obstacles. It passed off through the gold foil, and some of the alpha particles deflected from their original path. They got deflected at a noticeable angle. You can see the angle here. So this is noticeable by us, and you can see that very few particles, they bounced back at the original path itself. From the original path itself, they bounced back. So you can see that these are the observations made by Rutherford. So let's understand the postulates. What did he conclude by this? That most of the part of the atom is empty. According to the study, he found out that most of the part of the atom inside is empty. Yes, because most of the rays or alpha rays passed through the gold foil. That's why he made a conclusion that the part of an atom is empty. And you can see that they are positively charged center of the atom. Center of the atom is positively charged. And why some of it got deflected is because some of the rays hit this particular part, center of the atom, which contains the whole mass of the atom. So whole mass of the atom, and he named it as, which is called as the nucleus. So next is the size of the nucleus is very small as compared to an atom. Because of this experiment, only some of it which hit to the center of the atom or the nucleus, they got deflected. By this he found out that size of the nucleus is very small. And you can see that electrons, they revolve around the nucleus. So which revolves around the nucleus, that only got deflected, and otherwise it would have not passed most of the alpha particles through the gold foil. So let's understand some of the drawbacks. There are always limitations with respect to the scientific theories. Let's understand some of the drawbacks of Rutherford's model. So according to him, that electrons revolve around the positively charged nucleus. So he did not make a differentiation of the shell or the nucleus. He just told that the electrons just revolve around the positively charged nucleus, and which is not expected to be stable. So we can say that this electron is unstable, but protons are always stable. This is the limitation that Rutherford told about his experiment. And you could say that charged particle in an accelerated, a fast movement along a circular, that's round circular path, would continuously undergo, that is, they undergo loss of energy. So what did he say? Charged particle, if they are moving very fast in a circular motion, they will lose their energy, and finally they would fall into the nucleus. So you imagine that if the electrons, which is moving very fast, if it falls into the nucleus, then what would have happened? So that is a limitation with respect to Rutherford's model. So that electrons will never fall into the nucleus, and this makes the atom unstable. Finally, he concluded that this is why the atom is unstable, because electrons might end up falling into the nucleus. So, and also he found out that atoms are quite stable. So how this can match with? So he says that atom can be unstable and atom is stable, and which is very small in size. So this is where the drawbacks of Rutherford's model appears. So let's understand more drawbacks about it. This model could not solve the problem with respect to atomic mass. We have discussed in the previous topic of atom, and also it also proposed only the existence of protons in the nucleus. So protons in the nucleus only was told. He never told about the neutrons or the neutrally charged or no charged particles was not told in his experiment. So next, coming to Bohr's model of atom, and his full name is or complete name is Niels Bohr, and he did his model in the year 1913. His studies was done in the year 1913 with respect to the atoms. So model of atom, what does it states? So atom consists of heavy positively charged nucleus. So he found out that a nucleus consists of positively charged nucleus which is very heavy, and the whole mass of atom, so whole mass of the atom is concentrated at the center, that is only the nucleus. And also he told that electrons in an atom, they revolve around the nucleus in definite circular paths. So definite circular paths, and he called it as orbit levels or energy levels. As we have discussed previously, that is the shells, that is first shell, second shell, third shell, fourth shell, or K shell, L shell, M shell, etc. So that was discovered by Niels Bohr. So you can see here that positively charged nucleus at the center, and you can see that electrons moving around, and they have certain energy levels that was named as 1, 2, 3, 4 levels, and also K, L, M and N shells. So energy level is associated with the definite amount of energy in that particular shell with respect to the electrons. So you can see that change in energy, there is a change in energy when an electron jumps from one energy level to another energy level. So you can see that there is change from one energy level to another energy level when the electrons jump from one level to another. But actually we know that the first electrons, that is first level of energy of electrons, there are only 2 electrons always present, and rest of the shells will go or compete for the octet configuration. So that's all about this topic. We'll continue in the next part. Thanks for watching.